Okay, so we're looking at R10, and this is the integration part of velocity and speed. Just look at this. It's very clear. It helps you understand that there are three possible prompts. If you're asked for the displacement, and here's an example, what is the particle's displacement between this and this? Or what is the change in the particle's position? Then you're just doing the integral, which is right here, which is net change. Okay? If it asks for the total distance the particle has traveled, then you have to use the absolute value of the net change. And if they ask you where it is or what's the particle's position, you have to use the initial condition. So that's what, in general, this says over here. Take a look and read that. And then let's do these examples real quick. So the first example is just giving you a velocity function and saying at t equals 2, the distance is 5 meters from the starting point. It wants the total distance the particles travel between 2 and 6. Well, total distance would be absolute value. So if and I'm going to go down here, if you're looking at total distance, you're saying it's a net change from 2 to 6, but it has to be absolute value of v of t dt. And that's what that is, absolute value. So I just used the calculator and I got 40.837. Now, to do absolute value, if you can't use your calculator and you have easier numbers, remember you have to graph it to find out where it's positive and where it's negative. That's why this is split up to be 2 to where is the first time it goes from positive to negative. It was at 2 square root of 2. And so that would be negative t squared plus 8. And then you subtract the negative part, and that would be till 6. So 2 square root of 2 to 6 of negative t squared plus 8. And that's how you would have to calculate it separately. But it's nice when you have your calculator because you can remember, just use those absolute value signs. And let me know if you don't know where those absolute value signs are in your calculator. Go in example 2. It just shows us a graph. And you can't figure it out because they don't give you numbers, but it just says it wants the particle's displacement between 1 and 6. Okay, displacement is without the absolute value. It's not the total distance traveled. So it would just be from 1 to 6 of vt dt. And look at example 3. A particle moves in a straight line with this velocity, and t is in seconds. At t equals 2, the particle's distance was at 8 in the positive direction. So, it's positive 8. What's the particle's position? So now this one has to use the net change and the initial position because you have to say where I started at 8 and then I went on from here to here, from 2 to 7, and I had some more distance that I traveled. So that's why if you were writing this out on an FRQ, you would write position at 7 seconds is equal to f of 2, okay, what it was at 2, plus 7, or you could just put 8 since you don't really have the function, plus 2 to 7 of vt dt. No absolute value here, right? You're just doing the net change. So that's what you would do for that. And the last one I have is you're given acceleration, okay, and the velocity at the initial point, time equals 0 is 64, and the height at time equals 0 is 32. So it gives you two initial positions because obviously it's going to start at acceleration, then it's going to ask for velocity, then it's going to ask for position going backwards. So it wants the equation for the velocity. So here you go. Velocity is the integral of acceleration. So if it was negative 32 dt, you get negative 32 t plus c. Use that initial position to get v of t is negative 32 t plus 64. So that's no problem. Now height would be the integral of the velocity. That's what it asks for in B. So you would take the integral of this, and you get negative 16t squared plus 64t plus c. Use 0, 32, the second initial condition given, and you get this. There's h of t, negative 16t squared plus 64t plus 32. Now, here's interesting. You need to know how to do it. They ask for the maximum height. You got two ways. You can do it using pre-cal. You know that this equation is a parabola that goes like this, right? Or it's not exactly up there, but you know it's a parabola. And so you know that the vertex would be the maximum. And so remember how to find the vertex? The v of x is opposite of b over 2a. So if you have it in standard form, that would be negative 64 over 2 times negative 16. So you end up with 2 as the time that it happens, the maximum happens, and then you put 2 back into the original function to get the maximum height. Okay, and so you get 96 that way. Now, here's using calculus. So you have to set v of t equal to 0 to get the time, and then once you get the time, you go back into the original function to find out how high it is at that time, and you get 96 again. So it's 96 meters either way. All right, so that was a little introduction. Try those other motion problems that involve integrals, and then try the circuit training. Okay.